This is the homework helper for Chapter 5, Section 4 in the 8th grade textbook entitled Solving Proportions. Okay, so a few different options here when we're looking at questions 1 through 8 for solving proportions. We'll talk about all of them, even though I'm not going to do all of them with you. I will talk about all the different options rather with you. In number 1, we've got 3/4 and 9/12, and they want to know if those guys are proportional. So one of the things you can do is you can try and make the fractions the same somehow. Common denominator type technique, reducing, making a fraction bigger, whatever you have to do here. So let's go with a common denominator here. Common denominator of 4 and 12, the two that are listed there in number 1, would be 12. So that means the fraction on the right isn't going to change, but the one on the left will. To make 4 change into a 12, you're going to multiply that by 3. So you're going to do the same thing to the top. So this is 9 over 12. Well, the other fraction says 9 over 12 already. Since those two worked out to be the same, the answer there is going to be yes. Now, if we want to continue down that same idea of just working with fractions as fractions there, what we can do in number 2 is reduce the fractions and try and make them just go down to the same thing. That's another way we can prove that these two ratios are proportion, 9/24 and 18/48. So if I reduce the fraction that's on the left there, 9/24, that's going to reduce all the way down to 3/8. And if I go ahead and decide to reduce the fraction on the right there by chopping 6 out of the top and the bottom, well, here comes a surprise. Here's also 3/8. And since those went to the same thing, we have a yes once again. Now, you don't necessarily have to make them smaller. You could actually make them bigger. If we just took and doubled the fraction on the left there, notice that would say 18/48, kind of unintentionally a common denominator there. Just the fact that I made the fractions the same by doubling the guy on the left is another way we can say yes. In number 3, we'll employ another technique, probably a very simple technique. You can just find their decimal equivalents, and if you get the same decimal, the answer will be yes. And if you get different decimals, the answer will be no. So in this one, dividing here, so I'm going to take 16 and divide it by 24, and that's going to give me 0.6 repeating. And then I'm going to take 10 and divide it by 18, and that's 0.5 repeating. Since I got different decimals there, the answer is going to be no. Those ratios are not proportional. All right, and then the final option, which is probably my preferred option, would simply be employing the idea of cross multiplication. You can multiply the diagonals, and if you get the same result when you multiply the diagonals, the answer is yes. If you get different results when you multiply the diagonals, the answer is no. So with 13 and 50, I'm doing 13 times 50 there. 13 times 50 is 650. And the other diagonal with 26 and 25, I'm doing 26 times 25, and that's also 650. Since we got the same results there, our answer here is yes. If we would have gotten different results, my answer would be no. You can employ any one of those techniques you want, or any preferred technique at any one time in working through the rest of the questions in the top portion there. All right, so now let's go ahead and take a look at the bottom half from 9 on down. As you can see, we have all story problems to think about here. And we won't do them all, but we'll take a look at a smattering of them here. So let's go ahead and start with number 9. It says a karate team had 6 girls and 9 boys. So there's a ratio for us. 6 girls, 9 boys. And then what it says is 2 more girls showed up and 3 more boys joined the team. Did the ratio of girls to boys stay the same? So let's take that girl's number and add 2 like it says, 8. And take that boy's number and add 3 like it says, and that's 12. So they want to know if 6 9s and 8 12s are the same. Or are those two ratios or fractions, whatever you want to say, proportional? Well, if we reduce 6 9ths down, 6/9, if we chop 3 out, goes down to 2/3. Meanwhile, if I take 8/12 and chop 4 out, that also goes to 2/3. Since both of these guys went to 2/3, the answer here is yes. The ratio of the girls to the boys did happen to stay the same. All right, number 10. Janessa bought 4 stamps for $1.48. At this rate, how much would 10 stamps cost? So you've got a couple different options here. You can set yourself up a proportion that compares 4 stamps to 10 stamps, or you can figure out the unit cost, how much 1 stamp cost. Since we know 4 of them cost $1.48, we could divide out the 4. And then once we find out what 1 stamp costs, take that answer then and multiply it by 10, which would get me the 10 stamp cost. Obviously though, since this section is about proportions, they probably want us to do a proportion. So let's go ahead and do a little proportion here. We're going to say $1.48 for 4 stamps, and they want us to bubble this up for something compared to 10 stamps. Now notice the way I wrote that proportion, stamp numbers on the bottom, left and right side. Remember, you have to be consistent. If you decide to put that stamp number on the bottom, it's got to be on the bottom for the rest of your life. Or at least it's a problem anyway. All right, and the top is going to be that dollar amount, which we don't know what it is for 10 stamps, so that's where we're going to put our friend, the variable x. All right, when you're solving a proportion, we did this technique in one of the questions earlier, probably best off to cross multiply here. So on this diagonal, we've got 4 times x, that's 4x. And this other diagonal, we've got a 148 times 10. 148 times 10 is the same as 14.8. Solve the equation. Well, you know how to solve that equation. You're going to take 14.8 and divide by 4 now. When I take 14.8 and divide by 4, I get 3.7. So that means 10 stamps is going to cost me $3.70. All right, let's go ahead and take a look at one more question, number 13. It says, on a field trip, the ratio of teachers to students must be 2 to 9. If there are 81 students on the field trip, how many teachers must there be? So, teachers to students is 2 to 9. All right, that's from the end of the first sentence. All right, that means for every 2 teachers, there has to be 9 students. All right, so they want us to now figure out what this would work out to be for 81 students. So I'm going to write myself another fraction, and notice the way I'm writing this one is I'm putting the student number on the bottom. Why? Because I put the student number on the bottom on the left side. All right, so what we're figuring out is what's going to go here on this top part here, the number of teachers to make it go for 81 students. Now, we can cross multiply like we did up here, but there is a little bit easier approach that we really haven't talked about. Look at your bottom numbers here, 9 to 81. We know the relationship that takes me from 9 to 81. To go from 9 to 81, you're just multiplying by 9. So I'm going to do the exact same thing on the top. I'm going to take this 2 number and multiply it by 9. And that's how I'm going to end up with 18. So there must be 18 teachers there in order to make 81 students go on the trip.